Hello friends, in previous lecture we have studied concept of alternating series and its convergence. Now in this lecture we are going to talk about conditional convergence and absolute convergence of series. Okay? Conditional convergence and absolute convergence. Conditional and absolute convergence. Let summation of n equal to 1 to infinity be series of real numbers, then one summation of n converges absolutely if absolute means if I take series of absolute values of n's, if summation of mod n equal to 1 to infinity converges, and second summation n equal to 1 to infinity converges conditionally if summation of n equal to 1 to infinity converges and summation n equal to 1 to infinity mod n diverges. If I take example, say for series summation of n equal to 1 to infinity minus 1 raised to n plus 1 upon n. This series is nothing but 1 minus half plus 1 by 3 minus 1 by 4 plus the dot etc. 1 is greater than half, greater than 1 by 3, greater than so on, and limit n tends to infinity of 1 by n is 0. Therefore, by fundamental result on alternating series, summation of minus 1 raised to n plus 1 upon n equal to 1 to infinity converges. Now, summation of n equal to 1 to infinity mod of minus 1 raised to n plus 1 upon n. This is just summation of 1 by n diverges. So this series, given series is convergent, but its absolute value series diverges, and therefore by definition of conditional convergence series, given series is absolute convergence. From A and B, summation of n equal to 1 to infinity minus 1 raised to n plus 1 upon n converges conditionally. If I take second example, for series summation of n equal to 1 to infinity minus 1 raised to n plus 1 upon 2 raised to n. What is this series? This is nothing but half minus 1 by 2 square plus 1 upon 2 cube and so on. Summation of n equal to 1 to infinity mod of minus 1 raised to n plus 1 upon 2 raised to n is equal to summation of 1 upon 2 raised to n equal to 1 to infinity. This is nothing but half times 1 upon 1 minus half. half times 1 minus half. Is it clear? Which is nothing but 1. Since summation of a times x raised to n equal to 1 to infinity is equal to a upon x or x raised to n is x upon 1 minus x for 0 less than x less than 1. For 0 less than x less than 1. So it is 1. Therefore, summation of n equal to 1 to infinity of minus 1 raised to n plus 1 upon 2 raised to n converges absolutely. Absolutely. Okay. Now we will take the result that every absolutely convergent series is convergent. Okay. So theorem. Every absolutely convergent series is convergent. Is convergent. Okay. So proof of this, let summation of n, let summation of n equal to 1 to infinity n be absolutely convergent series. What this implies is summation of mod n equal to 1 to infinity is convergent. 1. Let Sn is equal to a1 plus a2 plus an and Tn is equal to mod a1 plus mod a2 plus mod a3 plus dot dot up to mod an for every n. Then Sn and Tn, then Sn and Tn are sequences of partial sums of summation of an and summation of mod n and summation mod n respectively. Okay. So from 1 summation of from 1 Tn n equal to 1 to infinity is convergent series and hence Cauchy sequence. Therefore, for given epsilon greater than 0, there exists positive integer n naught such that mod of Tn minus Tm is less than epsilon for any n greater equal m greater equal n naught. This is equivalent to summation of mod of a k equal to m plus 1 to n is less than epsilon for any n greater or equal m greater or equal n naught. This is 2. Now mod Sn minus Sm is equal to, for n greater or equal m greater or equal n naught, mod Sn minus Sm, this is nothing but mod of summation k equal to m plus 1 to n an, which is less equal summation of mod ak k equal to m plus 1 to n is less than epsilon, is less than epsilon. Okay. This implies Sn is also Cauchy sequence. Sn is Cauchy sequence. Which implies Sn is Cauchy sequence of real numbers and hence convergence. And hence convergence. Therefore, summation of n is convergent series. Is convergent series. Okay. So thus every absolutely convergent series is convergent. Every absolutely convergent series is convergent. Note, convergence is not true. Converse is not true. Example, summation of minus 1 raised to n plus 1 upon n equal to 1 to infinity is convergent but not absolutely convergent. But not absolutely convergent. Okay.